Hi folks! Today we will present by this title. How did our private cloud realize better application SLA using OpenVSwitch with DPDK? I'm Yusuke Tatsumi, a network engineer in Yahoo Japan, and
I'm Naoyuki Mori from Intel, works for NFV enabling and optimizations.
This is today's agenda. Let's start talk about our background. This is our portal site, web page overview. Do you know how much of the scale about this? These are the scale of our site. We have over 69 billion average monthly page views, and OpenStack private cloud supports many services. Recently, we faced some issues in network by rapid expansion of cloud. For example, cloud resources and users are doubling year on year. As a result, VM density is much higher than before. In addition to that, we often receive huge and burst traffic by serving breaking news or sudden weather update like earthquake. To serve such services, our compute node have to handle many short packets. In short, our cloud infrastructure requires much network performance. To overcome this issue, we have adapted OVS with DPDK as a vSwitch in HyperVisor. By the way, what is OVS with DPDK? Hey Mori-san, would you please explain overview about OVS with DPDK?
Sure, Tatsumi-san. Okay, let me introduce OVS without DPDK first. OVS is a well-known virtual switch that is commonly used in OpenStack. Native OVS uses kernel space for packet forwarding. As you may know, forwarding in a kernel space involves a performance overhead. Network performance will be limited. And DPDK is a technology that accelerates packet forwarding performance by bypassing kernel. To eliminate context switch overhead, DPDK won't use interrupt and won't copy memory from kernel to user, vice versa. It really boosts network performance. OVS with DPDK is a combination of these technologies. It's not only maintaining compatibility with native OVS, but also accelerate packet forwarding performance by integrated DPDK. There are several points for optimal performance deployment in OVS with DPDK. We'll share some tips we've applied. First one is a huge page. This is very important for a performance perspective. 1 gig page is best. And second one, right side, is CPU affinity. We have carefully identified optimal resources for each function, such as OS services and especially OVS PMDs. This figure, right side, shows our final CPU affinity design. Without this, performance won't be stable at all. With mitaka, you can easily deploy optimal OVS with DPDK. I believe that's why Yahoo Japan uses mitaka for this project. Right, Tatsumi-san?
Sure. Thank you, Mori-san. We have built new mitaka cluster, and OVS with DPDK runs with configurations as Mori-san mentioned. This is over 150 nodes and using Open Compute Project servers. So, how does OVS with DPDK improve performance compared with LinuxBridge that we currently mainly use? To confirm performance improvement, we have take two type benchmarks, network layer, and application layer. First of all, we have measured L2 network performance using Ixia IX network as a hardware network tester. We evaluated the red line on each vSwitches. These are the results. On the left side shows 10 times throughput performance improvement in short packet area. On the right side shows it can reduce latency up to 1/20th. By these results, we confirmed OVS with DPDK surely accelerate L2 path to VM. Next is application layer benchmark. In this test, one VM sends query and another VM returns response. All applications listed in this table shows performance improvement. Okay. Look at HTTP result and let's think about why. Checking the number of context switch, it is clear that OVS with DPDK environment reduce context switches. In other words, OVS with DPDK can raise the level of performance in this type of applications. Next, let's deep dive RabbitMQ results. In contrast to the HTTP good result, RabbitMQ results have a few performance improvement. Does it show the same trend under 10 VM to 10 VM test? The result shows that in LinuxBridge environment, the performance significantly degraded. Amazingly, OVS with DPDK environment can keep the performance. What happened? The cause also brought about by OVS with DPDK advantage. Under a noisy condition like this, much context switch happen in LinuxBridge environment. On the other hand, OVS with DPDK suppresses such noisy context switch. To summarize that, OVS with DPDK can keep performance even under real-world noisy condition. This is a key point to realize better application SLA in CSP use case. This is today's summary. OpenStack private cloud supports many services in Yahoo Japan. It is easy to deploy mitaka using OVS with DPDK. And as shown in previous slide, OVS with DPDK can improve application SLA. Through our project, we saw many issues and new findings. We would like to share and refer some expectations. To improve networking, aware of your network characteristics is much important than we thought before. This is a start point. We hope, as a large-scale cloud service operation point of view, a live update is necessary. We hope OVS with DPDK can do live update and live migration. OVS with DPDK is a great technology, not only for telco segment, but also cloud service provider can get benefit, as you saw in this slide. Try OVS with DPDK and share your any experience. That's all. Let's work together.